Hi, my name is Natan and I work with Keaton, and we chose to do the Gauges app on our iPhone. So, once you download the app, you'll get this icon with a bunch of different dials on it. And if you open it, you'll see a very large menu with a bunch of different options for readings that your phone provides. So, it's based off of the sensors built inside of your phone. And it works very well with the iOS system, and I don't know really how much it works with Android yet. We haven't tested that. However, what we've had so far is pretty good success with it. So, at the top of the menu, you'll see the altimeter. It provides a GPS-based altitude reading. Right now, it's fluctuating a lot, but it gives you meters and feet, as well as your pressure, altitude in meters, and as well as feet. And this will give you a nice graph that you can choose to segment or restart based off the app. And you can record if you bought the extra option. Below it, we can see that we have a speedometer. It does fluctuate at low speeds, as we can see right here, but it gives you both in kilometers per hour, miles per hour, and in knots. So depending on what situation you're in, it can be very useful. You can see it fluctuates very well, which is a problem. So we can see that the readings are not very good at at very low speeds, or not actually when they're supposed to be reading anything in terms of actual data. Below it, we have the barometer, where it shows the pressure around you in both mercury, psi, kilopascals, and in millimeters mercury. And below that, we see our accelerometer, which shows both our acceleration in all three directions, all three planes. But this is based off of the orientation of your phone. So right now, since my phone is flat, it measures the z-axis coming out of the back of the phone, by the camera, as -1 due to the Earth's gravity. But if I rotate it up, we'll see that the y-axis coming out of the bottom of where you charge your phone shows -1, whereas the z now pointed towards the wall is 0 or close to it. And we can see that the reading that it provides us is a sum of all three numbers. It isn't an individual list of each one. It would be nice if we could get a personalized reading based off each variable. That way we can eliminate these extra G-forces that aren't normally acting in the same direction as you're trying to measure. Below it, we have a magnometer, which shows the magnetic force of an object around it. So if I put it next to the phone, we'll see that the magnometer rises. If I bring it away, it goes down. This is useful if you're trying to find some sort of force with magnets, but it isn't useful in our application of our project. Below that, we have a sound level in decibels. Right now, I don't have my microphone enabled for the app, so it would read it if I did, but I don't want to enable it right now. And below that, we have our compass/location. It gives us our magnitude that I'm pointing. So if I rotate the phone, it provides a different magnitude. As well, it gives us our lateral location and our longitudinal location, as well as a pinpoint location on a map of our area around us. As we can see, I'm still in Berkeley. And yeah. Below that, we have our luminance. And if I had my camera enabled for the app, it would show us a different luminance reading, but I don't have that enabled right now, so it doesn't read us anything.
Based on the recordings in the app, we chose to use the accelerometer gauge. In order to test how accurate and functional the accelerometer was, we chose to time our 0 to 60 in a car, while simultaneously using the accelerometer on the Gauges app to cross-compare the Gauges app's accuracy versus the accuracy of raw calculations. On our first trial, we found that we pulled a max of 0.8 Gs in the horizontal direction. And on our second test, we pulled 0.7 Gs, which means that the app is fairly consistent in the readings we get. Now, to compare this, we also took the time it takes for me to go from 0 to 60 miles an hour and found that it took around 8.94 seconds which when you use a calculator going from 0 miles an hour to 60 miles an hour in 8.94 seconds, gives you an average of 0.34 Gs of acceleration. Now, this number is fairly consistent with the Gauges app, where if we look at the graph and the values given and average them, we are given close to 0.45 Gs of constant acceleration. The app is good in that way because it gives you very accurate numbers without having to calculate your velocity at a given point. However, there are some drawbacks. For instance, the graph itself doesn't have super accurate numbers, and there's no way to interact with it, export it, or pull the data points directly from the graph, which means you need to rely on the given data taken from a video similar to what we did. Additionally, the graph itself is affected, for at least a car, by things like bumps in the road, which affect your Z acceleration, which can add to or subtract from your total Gs, which means you need to focus on the given plane of acceleration that you've chosen. However, if you're on a hill or anything like that, things can get kind of complicated as you're accelerating in multiple directions at once. In order to further test the accuracy and consistency of the Gauges app, we utilized a different vehicle to conduct 3 more tests of 0 to 60, for which we got times of 10.8, 10.6, and 10.8 from the Gauges app, and saw that it was fairly consistent. And since this car had a automatic gearbox rather than the manual in the first car, the graph was much more consistent, which aligned with the jerkiness of the first graph. This last set of tests confirmed for us that the Gauges app was very, very accurate and consistent in the data it got, seeing as across both multiple trials and on multiple vehicles, you get consistent results which line up with manually calculated data. And now for a rating. It seems most fair to give the Gauges app a rating of around 4 stars. The data that you can get from the app, and if you utilize it well, is very good and very consistent. There is a multitude of options available on there in terms of readout, and it gives you all 3 different directions of G-forces you can have, which further, it makes the data much more useful when it comes to actually taking it and implementing it. There are some downsides, though. All of the data is contained within the app, and there's no great way to export it. Some of the features contained within the app are blocked behind a paywall, which means there is a cost component to the app, which is disappointing. And then finally, the graph itself is very limited. It has no real numbers, and all you're given is sort of a range between the 2 largest and smallest values. Additionally, there is no average you can find on the graph, and there's no way to know what your average G-forces pulled was. Overall, as I said, it gets 4 stars, which seems to be fair for the value it provides along with the drawbacks it has.